Hey, what's going on, guys? In this video we are going to take a look at flip-flops. Here we have D flip-flop, and you can see for D in flip-flop, if D is 0 and Q is 0, Q asterisk is 0, and if D is 0, Q is 1, Q asterisk is this next state, that's equal to 0. And when D is 1, Q is 0, Q asterisk is 1, and when D is 1, Q is 1, Q asterisk is also 1. Now from this one you can see a direct relationship between D and Q asterisk. When D is 0, Q asterisk also 0. When D is 1, Q asterisk also 1. Okay, that's the relationship. Now let's look at the SR flip-flop. SR flip-flop is when S is 0, R is 0, Q asterisk is Q. And when S is 0, R is 1, Q asterisk is 0. When S is 1, R is 0, Q asterisk is 1. And when S is 1 and R is 1, Q asterisk is not allowed. Okay, and that is SR flip-flop. Now let's look at the JK flip-flop. JK flip-flop is when J and K are 0, Q asterisk is Q. And when J is 0, K is 1, Q asterisk is 1. When J is 1 and K is 1, Q asterisk is Q. And if you look at T flip-flop, this is also called as toggle flip-flop. That is when T is 0, Q asterisk is Q. When T is 1, Q asterisk is Q bar. Now here we are going to take a look at toggle flip-flop and JK flip-flop a little bit further. Let's get rid of this D flip-flop and SR flip-flop. Now if you expand JK flip-flop including this Q, it's going to look like this. J, K, Q and Q asterisk. When J is 0, K is 0, Q asterisk is Q is 0, so Q asterisk is also 0. When J is 0, K is 0, Q is 0, actually Q is 1. Q is 1 and then Q asterisk is 1. When J is 0, K is 1, Q is 0, Q asterisk also 0. And when J is 0, K is 1, Q is 1, Q asterisk is 0. Then when J is 1, K is 0, Q is 0, Q asterisk is 1. And when J is 1, K is 0, Q is 1, Q asterisk is 1. When J is 1, K is 1, Q is 1. And then J is 1, K is 1, Q is 0. And then Q asterisk is 1. When J is 1, K is 1, Q is 1, Q asterisk is 0. This is the JK flip-flop. Now let's go ahead and draw the K map for this. Zero, zero, 0, 1, 1, 1, 1, 0, 0, 1, and this is Q, and here we have JK. But 0, 0, 0, JKQ 0, 0, 0, we get Q asterisk to be 0. And when JK is 0, 1 and Q is 0, 0, 1, Q is 0, we get 0 again. When JK is 1, 1 and 0, 1, 1 and 0, we have 1. And when JK 1, 0, Q is 0, 1, 0, 0, 1, 0, 0, we get 1. And when JK is 0, 0, Q is 1, 0, 0, Q is 1, this is 1. And when JK is 0, 1, 0, 1, 1, we get 0. 1, 1, 1, we get 0, 1 0 1, we get 1. Okay, now from this one we can solve for q asterisk. Q asterisk is basically j. If we connect this one like this one, we can connect together, and this one we can connect to the together. From this one you can see this is jq bar plus k bar q, and this is q bar from k map. Okay, this is how we can write the q bar for jk flip-flop. Now let's look at the toggle flip-flop. For toggle flip-flop, you can see when t is 0, q asterisk is q, and when t is 1, q asterisk is q bar. And if you include q and q asterisk bar, it's going to look like the table. We can expand the toggle flip-flop table a little bit. T q asterisk bar. If this is 0, this is 0, this one is 0, then this is 1, 0, 1, 0, 1. This is 1, 0, 1, 0, 1, 1, 0, 1. Okay. Now if we throw the AND gate for this is going to look like this. We have T and then Q bar. And here we have OR gate. This is Q and this is T bar. Output is Q asterisk bar. And that's how we draw the T flip-flop, toggle flip-flop. And that's how we do this kind of, that's all about flip-flops. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn digital logic design 2 or computer architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.